Hey, this is Mr. Molo for lesson 5-4, solving special systems of linear equations. So kind of expanding on what we did the last couple days, except today they're going to throw some new things at you, kind of a curveball. They're going to throw many solution and no solution things at you. So if we look at it here, so one solution is pretty much going to be everything that we've done the last couple days. You're going to have two lines, they're going to cross at one point, and that one point is the one solution. So whatever, if it was, 2, 3 or something, that's our one solution. X has to be 2, Y has to be 3 for these equations to work. No solution, you'll see the lines are parallel. So that means they're never going to cross, they're never going to have a solution. So therefore, there's not any answer. So no matter how hard you work at it, you're never going to find an X and a Y that make that equation true. And then here, infinitely many solutions, they're the same lines. And these are tough to see on a graph because it's literally the same graph that's on top of each other. Okay, so if we look at it here, going back a page, so we have A, B, and C, and there's one of each. One's a many solution, one's a no solution, one's a one solution. So here we have A, that would be a one solution problem. So when we graph these, it'll have one solution, and that one solution is where it's crossing, which in this case, it is crossing at 0, 2. So the one solution for this problem is 0, 2. There's never ever going to be another number that makes this solution true. Okay, B, we have two parallel lines, and they're not crossing ever. So since they never cross, that is a no solution problem. Okay, never going to cross, so never going to have a solution. C looks kind of weird. It looks like we have two different lines, y equals x plus 2, and then negative 2x plus 2y equals 4. And the best way I can explain this is that they're the same line, but they're kind of like fractions. So if I say, oh, I'll give you 5/10 of my money, or I'll give you 1/2 of my money, well, that's really the same thing. They don't look like they're the same. Some people might be like, oh yeah, 5/10, woohoo, but that's really the same as 1/2 of your money. Okay, it's kind of the same thing here. If I were to, add 2x to each side here, and so I get y equals x plus 2, and then I have 2y equals 2x plus 4, we kind of can see a little pattern here. Well, here's a y and here's a 2y. Here's an x and here's a 2x. Here's a 2 and here's a 4. Well, this one's really just disguised, and if I multiply that whole thing by 2, I really kind of get the same answer here. 2 times 2y, or 2 times y is 2y. 2 times x is 2x. 2 times 2 is 4. They're really the same equation. One's just more simplified. Kind of like the same thing here. 5/10 is really the same as 1/2. It's just more simplified. So same thing. I could say, oh, I'll give you 4/8 of my money, or 3/6 of my money, or 2/4 of my money. And they all really just mean 1/2 if we simplify it. So here, y equals x plus 2 is simplified. Here, 2y equals 2x plus 4 isn't really that simplified. I could multiply the top one by 2 or divide the bottom one by 2, and I still get the same answer. Okay, so I'm going to write down some tricks here for us, because most of the time we're not going to graph them, so then we're going to have to do some work to see. Okay, so this only works if it says they both say y equals, or the x and the y are on the same side, so they have to be in the same form. Okay, so that's kind of our first trick. So make sure they look the same. Okay, one solution, that one's the easiest to tell. You will have different x's and different y's. Okay, if one of them is different from each other, you know it's a one solution problem. Okay. No solution problems, you need to have the same x and the same y. So notice how I use the word and there. Both of them need to be the same, versus one solution, only one of them needs to be different. So for no solution problems, same x and same y, but they'll have a different number. Okay, so one might be like x plus y equals 7, and one might be like x plus y equals 3. Well, they both have one x, they both have one y, but the number is going to be different. And then many solution means everything has to be the same. When I say everything, I mean everything. Same x, same y, same number. And remember, when I mean the same, it could be something that could be simplified. So like that first example, x plus y equals 2, 2x plus 2y equals 4. Okay, those are really the same thing because this is just this multiplied by 2. Okay, let's look at some examples here. Okay, so here for number 1, we have y equals 3x minus 7 and y equals 3x plus 4. Okay, y's, they're the same, check. X's, they're the same, 3x and 3x, check. But our numbers are different. Our numbers are a negative 7 for the top one and a positive 4 for the bottom one. Well, that's a little different then. So if I go back and look at my cheat sheet here, so they have the same x, which is a 3x. They have the same y, which is a 1y, but they have different numbers. It's a negative 7 and a positive 4. So this one's going to have no solution. Okay. Number 2. Let's look at the y's. Y's are the same again. 1y, 1y. X's, however, are different. Kind of tricky. This is a positive 5x. This is a negative 5x. Those are not the same. One's positive 5, one's negative 5. So this is going to be a one solution problem. And then it wants you to solve that one solution problem. For this problem, you might want to graph or do substitution, or you can even do elimination since they're right on top of each other. So you can kind of pick which way you want to do it. My favorite is elimination, so that's which way I'm going to do. And I believe for this one, we end up getting a fraction. So, all right. So I'm going to add everything together to get my y's or my x's to cancel. So y plus y is 2y. 5x plus negative 5x cancels out at 0. And then negative 1 plus 5 is 4. So divide both sides by 2. So I figure out my one solution for this problem, y equals 2. I still need to figure out what my x is. So I'm going to do some work up here to figure out what my x is. So instead of y equals, I'm going to put 2 equals. And I get 5x minus 1. So I'm going to add 1 to both sides. And then divide by 5. So that gives me 3/5 for my x. So like I said, kind of weird because it gives us a fraction there. So my x is 3/5 and my y is 2. All right. Number 3, I have a 2x and a negative 2x. Okay. I have a negative 3y and a positive 10y. Well, that's weird. They're the same number, but they keep being opposite signs. And then I have a 10 and a negative 10. Okay, so that's really weird. I have a positive and a negative and a positive and a positive and a negative again. So it's, again, one of those things I talked about where this one can really be simplified. If I multiply this by a negative 1, then 2x times negative 1 is negative 2x. Negative 3y times negative 1 is a positive 3y. 10 times a negative 1 is a negative 10. Now if I look at my two equations, negative 2x, they're the same. Positive 3y, they're the same. Negative 10, they're the same. Or let's say we didn't see that. Let's pretend like, oh, Mr. Muller, that's hard for me to see. Okay, fine. Go ahead and solve the problem. Here's what it'll look like if you solve a many solution problem. So I'm going to add to get everything to go away. 2x plus negative 2x, 0. Negative 3y plus 3y, 0. 10 plus negative 10, 0. Does 0 plus 0 equal 0? Yes, it does. It is many solutions. Okay, now that I think of that, let's go back and solve this no solution problem and see what we get there. So I need to subtract here to get my y's to cancel. So I'm going to subtract y minus y, 0. 3x minus 3x, 0. Negative 7 minus 4, negative 11. Well, that's funny. Does 0 equal negative 11? No, it doesn't. So no solution for that one. That's another way to do it. If you just want to go ahead and keep solving the problem like we've been doing, perfectly fine. Keep solving the problem like we've been doing. Okay? Otherwise, some of you might be able to see it a little faster and just be like, oh, these are the same or these aren't the same. So you can do it like that. Okay? So 4, let's look at this one. So let's just pretend that we don't see the pattern or we didn't copy Mr. Muller's cheat sheet back there on the last page. So I'm going to add to get my x's to go away. So x plus a negative x is 0. 3y plus a negative 3y is 0, and 6 plus 3 is 9. Well, does 0 plus 0 equal 9? No, it does not. That is a no solution. And then kind of the same thing, if I multiplied here by -1, I would get the same x's, I would get the same y's, but I wouldn't get the same number. So -6 and +3 aren't the same, so that's not going to be the same here. Okay? Here, same thing. Let's add to get everything to eliminate. 6x plus a -6x is 0. 6y plus a -6y is 0. -3 plus 3 is 0. Well, 0 plus 0 equals 0. Yes, it does. So this is a many solutions. Or again, same thing. If I multiply this top side by -1, it will look exactly like that bottom side. Okay. Here, let's say my y's are the same, so I'm going to add to get those to eliminate. 2x plus 3x is 5x, so I already know it's going to be a one solution problem because I added everything together and I didn't get 0 x's and 0 y's like I did here. So I already know it's going to be a one solution problem. -5y plus 5y is 0, those eliminate. And then -3 plus 8 is 5. So divide both sides by 5, and we figure out that x equals 1. And I'm going to plug it into that bottom equation. I don't like dealing with negatives. So 3 times x is 3, plus 5y equals 8. So subtract 3, 8 minus 3 is 5, divide, so y equals 1. Okay. Otherwise, the rest of this work is pretty much the same. You'll see the numbers kind of get bigger, but that doesn't really change anything. I'll do these last 3 kind of the fast way one more time, so we'll kind of see how it goes through. So I have a positive 2x and a negative 2x, a positive 3y and a positive 3y, so both positive 3y's, and a 1 and a -7. So right away I kind of see, well, 3y and 3y are the same, but my x's aren't the same. So if you remember, x's or y's are different, so my y's are the same, but my x's are different. So this one's going to be a one solution problem. Okay, here we got 4x and -8x. Okay, those aren't the same. 3y and -6y. Okay, those aren't the same. And 17 and 34. But can I multiply that top equation by something to make my x's and y's the same? And the answer is yes. I can multiply it by a -2. So everything gets multiplied by a -2. So I have -8x minus 6y equals a -34. So now if I look at my two equations, they look a little more similar, but not exactly the same. -8x, -8x, yep. -6y, -6y, yep. But -34 and +34 aren't the same. So the x's are the same, the y's are the same, but the numbers are different. So this is a no solution problem. Okay, and the last one we'll look at, number 9 here. So same thing, 3x and -9x, okay, not the same. -2y and 6y, not the same. 6 and -18, not the same. But again, we notice some kind of pattern. 3/9, 2 6, 6/18. I could just multiply this top one by -3. So I multiply everything on the top equation by -3. 3x times -3 is -9x. -2y times a -3 is a +6y. And 6 times a -3 is a -18. So now if I look at it, -9x, -9x, they're the same. 6y, 6y, they're the same. -18, -18, they're the same. So this one is going to be a many solutions one. So whichever way you want to do it, if you want to keep solving it like we did on these 4, 5, and 6 there, then go ahead and keep solving them like normal. Or if you kind of want to write down that cheat sheet that I have here and can kind of see it a little faster, either way, you're going to get to the same answer. One just might be a little faster than the other one.